Hello, this is Dr. Harrington, and we are at Lecture 6, page 5. So we can do some applications. Let's start doing them. A Florida citrus grower estimates that in his grove, if 60 oranges are planted, the average yield per tree is 400. The average yield per tree will decrease, so again, let me underline some key words here, decrease by 4 oranges if each additional tree is planted. Express the yield y in terms of the number of additional trees. So let me just give some details here before we start doing any problems. So this is additional trees. So in other words, if I write out if x is equal to 0, then we actually still have the original 60 trees. We have 60 trees. If x is equal to 1, then we have 61 trees. Now let's figure out how much our yield is. So if we have if x is 0, then our yield, then the number of oranges is 400. If we have one extra tree, so we have a total of 61 trees, then the number of oranges that we produce decreases by 4. Number of oranges is actually going to be 396. Okay, now the question is, how many trees should we plant to maximize the yield? That's what we want to do. Okay, so now that we understand how the x's and the number of oranges are involved, let's actually figure out what our yield is. So our yield is going to be equal to, that's the number of trees times the number of oranges per tree. Again, that's per tree. These are 400 per each individual tree. So the yield is going to be the number of trees okay, and then we're going to have times the number of oranges per tree. Okay, now I'm going to get the number of trees. Well, remember, if x is 0, we have 60 trees. If x is 1, we have 61 trees. If we have x is 2, then we have 62 trees, so forth and so on. So the number of trees we have is, we start off with 60 trees, and then in addition, we have x number. The number of oranges per tree, remember, we start off with 400, but it decreases every time we add on a tree. So that's going to be minus 4x. Now what you'll see here is that this is a nice little polynomial. Now if I multiply this out, I'm going to get y is equal to, if I take 60 times 400, I get 24,000 plus, and then I'm going to add that, get 400x minus, and then the other term, 240x minus 4x squared. And let me clean this up just a little bit. This is going to be y is equal to negative 4x squared plus 160x plus 24,000. Now what you'll notice is, again, the leading coefficient is negative. So what that tells us is that it's going to be going down. It is a downward parabola. So we know that we're going to have a maximum amount somewhere. So the question is, how many should we plant? Okay. So the first thing I'm going to do is I'm going to do x is equal to negative b over 2a. So that's going to tell us how many we should actually plant in addition. So I'm going to have negative 160 divided by 2 times negative 4. So again, this is my a and this is my b. So that's going to turn into 160 divided by 8. The negatives cancel out, and I'm left with 20. So I'm actually planting 80 trees, because remember, this is in addition to the original 60. Now my actual yield for this, I'm going to plug this back into the y is equal to 60 plus x times 400 minus 4x. So I'm going to get y is equal to 60 plus 20 times 400 minus 4 times 20, which this just turns into 80 times 320, which is going to be a yield of 25,600 total oranges. Now, what we're going to do is figure out how many oranges should we plant. So what we need to plant is we need to plant the original 60 that we have down plus the 20. Remember, that's the 20 that we had there. That's the one we have in addition. So we need to plant in a total of 80 orange trees to maximize our yield.